Let's use synthetic division to go ahead and divide this fourth degree polynomial by a first degree polynomial. So as we want to get going on this, synthetic division requires us basically to go ahead and grab the coefficients for each one of these terms. So we're dividing 3x to the fourth plus 18x to the third, and then I notice we skip over the power of x to the second. So what we're going to do is need a placeholder there of 0x to the second powers minus 3x to the first powers, and then a positive 40 for our constant at the end. I'm going to go ahead and skip a row, leave it blank for now, and just draw a nice horizontal line. And we're dividing by a special linear polynomial here. It's 1x to the first power, plus a number or minus a number. If it were 3x or x to the second power, I would really advise against using synthetic division. But ours fits into a nice pattern here. So next what I want to do is I want to think to ourselves, all right, we have what value of x could we fill in for this x to make this equal 0? So in our case, we'd say what plus 7 makes 0? So negative 7 plus 0 plus 7 makes 0. So negative 7 goes out in front here. Next, what we're going to do is basically follow synthetic division is going to have us first multiply. And it's always multiplying by that value that goes out in front. And then add vertically. Okay, so the first digit here, the 3, is just going to come down to the front, down to the bottom row. And now we start our synthetic division process. Remember, we're going to multiply first. So negative 7 out in front, multiply by the value at the bottom. Negative 7 times 3 makes a negative 21. Now we're to the add step. So positive 18 plus negative 21 makes negative 3, goes at the bottom. Now we repeat, we're back to the multiply step. So negative 7 in front, multiplied by the negative 3 at the bottom, makes positive 21. Next, go ahead and add 0 plus 21, makes positive 21. Now these values are going to get kind of big kind of quickly here as we're multiplying negative 7 times positive 21, works out to be negative 147. We add negative 3 plus negative 147, makes negative 150. Multiply, we're getting really big numbers here. Negative 7 times negative 150 makes positive 1029. Last addition, we have 40 plus 1029 makes 1069. So that completes the process because we're done. We're out of values at the top, but how do we interpret this? All right, to read our solution, this last value we got to, that's going to be the remainder. All right, the rest of this makes up the quotient. All right, but remember with synthetic division, it's only the coefficients basically are going on here. So the value, the negative 150 that's right next to the remainder is going to be a constant term. It's going to just be a number. The 21 gets x to the first power with it. The negative 3 is going to get an x squared with it. And we just keep stair-stepping our way up and increasing the exponent by 1 as we move to the left. So overall, the quotient can be rewritten as 3x to the third power minus 3x to the second power plus 21x minus 150. All right, that's the quotient. Sometimes we say our overall solution is the quotient plus the remainder over the divisor. Remember, we divided by x plus 7, so x plus 7 can go down here. So all of this at the bottom is the quotient, but then sometimes we write our solution as the quotient plus the remainder over the divisor. So I hope this helps out as you're getting used to using synthetic division to divide polynomial functions.